Good enough, Discord? Hello.
Yes, yes.
Okay.
Yes, yes.
So we start off with making rectangles, and this is problem A. If we keep them like this itself, it will be perimeter of this plus perimeter of this plus perimeter of this. We need to minimize this perimeter. So to minimize it, we need to coincide uh, these rectangles, right? So what is the best way to coincide the perimeters? You can just place the start of all the rectangles at 0 comma 0, like any point like this, and then just add the perimeters, and then what you will have left is a rectangle with the max width and the max height. So your answer will be this whole square. This whole will be your answer as a perimeter. Now, why am I taking this extra thing as my perimeter? Why do I need to take this rectangle as my perimeter? Well, just observe. This thing that is extra, it has to be counted in the perimeter, it goes up. This thing that is extra, it has to be counted, it goes up. And this thing that is an extra after this goes fits in perfectly here, and this thing fits in perfectly here. So my perimeter is exactly the same as the rectangle of the max height and the max width. So that's what you have to do. You take inputs, height, width, get the max height plus max width, basically this part multiplied by 2. Basic geometry. That was A. Any doubts? Hello.
No, no.
Okay. Continuing to B. B is Stalin sort. So what does this do is, let's say I have like I start over here. I have a number. So any number that is less than 6 will be removed. Will be removed. Will be removed. Will be. So let's say if these numbers, all of them are less than 6, all of them will be removed. If there is a number greater than 6, now this becomes the new number, and any number less than this new greatest number is removed. So in hindsight, you can say if a number is less than the prefix max of all of the indices before it, then it is removed. That is basically what happens. Now we need to make the array non-decreasing after removing a few numbers. That array is called vulnerable, and we can remove the numbers of any kind of a subarray, right? Now you can always see that the first element is never ever removed. So you can iterate on your first elements, right? So let's say the first one is my first element, the second one is my first element, the third one is my first element, the fourth is my first element, or the fifth is my first element. You can iterate on these first element and then check what all things to remove. So what all things to remove? Anything that is greater than the first element has to be removed, or else it will be part of my array, right? So if I have something called as x here, and rather I have an x here, and this thing is some value x plus y, where y is a positive integer. So this will be the new value, and if I run a Stalin sort in this whole array, I won't be able to sort it out, right? So I have to remove this. Then we move ahead, and so on. But and same thing if this is something like x plus y plus z. So we remove this too. Now what I can do is I can cut off this x, and I can move here, and anything that is greater than this will obviously be removed, and this will also be removed, right? So that is how you can get the removals, and just simulate for n square. The time complexity of this algorithm will be n squared, right? So coming to the code, you take input of the array A, and you remove exactly I minus 1 things. So if you are at index 1, you remove 0 things. And because we are following zero based indexing here, I haven't taken I minus 1. And rest, if anything is greater than my current element, we just remove that, and we want to find the minimum of this. That's how this works. Any doubts? Hello? Hello?
Yeah. I had a doubt actually. Was there
Huh.
a DP solution possible here?
Was there a dynamic programming solution possible here? What you are doing is dynamic programming only, you could say, because what
Yeah.
uh like starting at index I, uh like you can't say. Basically I'm storing it, so like you could call prefix some dynamic programming, because you are storing the sum till index I. So till index I, the minimum thing that I'm storing. So like this solution in itself, if you consider this solution as DP enough, that index I stores the minimum value to remove till all indices I, then this is else. I don't think, I can't think of any other solution.
Okay.
Okay. Any more doubts? No. Okay.
Yeah.
Huh?
Play any.
Okay. Great. Now continuing, problem C. This shouldn't have been this hard, but it just became. Uh, so what do we have here? We are given an array, some values in the array, and I can remove. So what I can do is I can select a value if and only it if and only if the value AI is exactly equal to size of A minus I plus 1, if I'm not wrong. This is it? Yes. So this is the time I can select this value AI. If AI is exactly equal to this. Once I select it, I add a bunch of zeros at the end of the array. That means the size of the array increases. Correct? So I want to find the maximum length of my array. Okay, great. So how do I do this? First thing is, uh, like there will be, I can select every index at most once. Why is that so? So let's say I have this index value something AI, and I add a few zeros over here, right? I add I minus 1 zeros over here, and I can't be 1, so I can't select it again and again and again, same index. So there will at least be a 0 added. So if zeros are added, this A increases in the equation, rest all remains the same. So it can't be equal, right? So this will be basically A plus some sort of X. So one thing is very clear, that we can select one index at most once. Great. We can select one index at most once. That is great. Now, what I can do is, okay, then what I can do is, let's say I have an array size of Y. There will be a few indices I'll be able to select, right? I'll just select all of those indices and get new array sizes, some Y plus Y plus A, not A, let's say PQR, Y plus P, Y plus Q, Y plus R, right? Because these numbers will be on different indices. And after this Y plus R, I again go ahead and select few more indices and select few more indices and again select few more indices, right? and let's say y plus p, there were two such indices that require the array size to be y plus p, right? For every index, this way I can select the desired array size. So for some sort of an index, the desired array size, we just map this equation again, is a of I plus I minus 1. So this is the desired array size. So yeah, so if at a desired array size I have few more indices, and I just need to know what is the max value when I keep on traversing ahead and ahead. What is the max value that I can achieve? After this, let's say there's zero thing, so I just stop here. But this is the max length I could achieve. Let's assume y plus q plus some x. Yeah. So this is the max length I could achieve. That's great, right? So what does this look like? This is a graph. And what do we need to do in this graph? We have to do a BFS or a DFS, whatever you feel like. So we traverse the graph, and whatever is the maximum value of the node that is reachable in the graph, we get it, right? So that's what we have to do. Our adjacency list will look something like the desired array size. So that is desired array size, desired size, and in that list I'll have all the indices that can move it ahead. So just that can, like, that desire that size. Let's say I have index 2 and index 4. Desired size is, let's say, 5, and index 2 and index 4 require the size 5, and then from 4 I can go forward. So again, let me just uh, dry run this thing. I feel you'll understand it more better. This is very mathy, right? So we'll take this example, right? So let's take this example. And how do we do this? So the so 2 I can't take it, so let's just cut it off. 4, what is the required size? 4 plus 2 minus 1, right, which is 5. Here the required size should be 8. Here it should be 5. 5 plus 5, 10 minus 1. Here the required size should be 9. So, okay, so I have 5 as required sizes. I can just start my BFS from here, right? So my adjacency list, you could say, will look like, so desired size would be 5, and I have indices 2 and 4. So index 2 and index 4. So when 5 comes in, what do I pass it on to? I will go to 5 plus 2 minus 1, and I'll go to 5 plus 4 minus 1. Correct. I'll go to these indices, right? So 5 plus 2 minus 1 is, what should I, 6, and this is equal to 8. In my adjacency list, there's another 8 of the desired size, and we just traverse this whole graph. So for those of you to understand the adjacency list, what an adjacency list is, basically this. So 6, 8, and then from 8 you'll move on and on and on. So that's what I've done. Coming to the code, I have written a BFS, and so here is my adjacency list. Here is the BFS queue. So 1 I'm not inputting. If the target size is exactly this, then we just push I minus 1. I'm directly pushing I, no need to push I, because I can directly sum it. And if the size is exactly n, then I can start. And I'm maintaining a visited array in the graph itself. And this is just a simple BFS code that is happening. And instead, and the size can go n squared. So we can't maintain a visited array. So therefore, I'm maintaining a visited set. And if it's not present in my adjacency list, I'm again not going forward. Same thing. And if I'm able to reach a certain point, I have my answer. Understood? Hello. Any doubts in the BFS solution? Hello.
No, no doubts.
Okay.
No, no.
Okay. Now coming to D1. How are we supposed to write D1? Hmm. Okay. So D1. Oh, okay. So what we are given is oh yeah, no need of BS. Yes, like this condition makes it not necessary. Okay, fair. Okay,
There is a
so what we are given is, let's say, a value. Sorry. Okay, we are given two arrays, A and B. This, let's assume this is my A, this is my B. The goal is to make A empty and to do it in at minimum cost, right? So how do I make, and in one operation what I can do, I can just, I can remove array a prefix of array A that is less than the current index I am at of B, and these indices I can only move forward, I can't go backwards. So what in my solution I've done is I've written literally a DP, so there isn't a requirement of this condition, bi is greater than bi plus 1. But like I'll share both solutions, or the second solution can be shared by Janil if he gets uh yeah, because he had the approach. And yeah, so coming ahead, how do we do it? uh we have A, we have B, and now what I do is dp of I comma j, right, denotes that I am at the ith index, ith index in B, right, ith index in B, and I have removed all values till the jth value in A. This much everyone understood. What does a state in the DP table mean? Hello. Yes. Okay, great. Ith index in B is a jth value in A. Okay. Now coming to a transition. How do I transition? How do I make use of storing this state and transition ahead? Okay, let's see. So what I'll do is I can make the table. Let's just make the table this way, and here and here. Let's call these B1, call this B2, let's call this a B3. Let's call this A1, A2, A3, A4, and A5. Okay. Now, how do I transition from point A to point B? First thing is, I can take the value that was before, like, I can take the value that I took to transition till A2, right? So, uh, okay, let me just explain in a bit better way. Let's say I am at B1, right? Now, it took me some X value to remove all of these till A2, right? Now, to remove all of these till A3, it is like, let's say A3 is also removable with this B1 value. So it is going to take me X plus 3 minus 1 as a value, right? If I remove just the 3. But there is a way that I can also remove A4, because let's assume that it comes in my a3 plus a4 is also less than b1, and a3 plus a4 plus a5 is also less than b1. So how do I know till where I will transition, or rather use this value in x? It could be here, I could have gone till here too, and I could have gone till here. So till where should I use? I can literally binary search for my prefix till where it will end. So a3, a4, a5. So after a5, I remove x. I cannot transition from x, right? And every time I am going to add x plus, I am going to add the minimum. So like this is just the first transition. What if I had a 0, and from the b1 I could transition through, sorry, from a1 through a5 I could transition the whole array in this single b1. So I would have a 0, and I would have a 0 here also, something like that. But let's say I couldn't transition, I could transition only till a2, and I couldn't transition till a5. So I would have my x somewhere, let's say here. I could transition from I would transition a3 and a4 both, right? I could have transitioned 0 through a2, right? So for a3, I have inserted this, and it will be removed over here. 0, I could transition from 0, I could transition only till a2. A2 will be removed here. So I will always take the minimum value. So transition from value, that value, the minimum of all those values, min of all these values, plus the in m minus I. So that is how I just construct my DP table one by one by one by one, and I get my answer. So how do I maintain all these values? I can maintain all these values in a multiset and store these in a vector. So as and when a vector arrives, I'll just add a x. Like I'll just remove x from the multiset. I'll remove a 0 from the multiset here, and then give this thing a value. So this is how you can just transition. You can binary search till a certain value, and till that value you can go and you can maintain a multi-set. So coming to the implementation is basically I have a prefix sum, I have a bi, and n plus 1. I'm setting everything over here to a 0, right? There is no need to set to a 1 because I can directly transition from here itself. And here is my vector, and I have a multi-set. Anything that was part of it, basically part of this vector, anything that I had to remove, I'll first remove it. Then I'll set my dpi to the above one, basically the smallest way to reach here, to reach what do you say, b2, using b2, whatever you want, smallest way to reach here. And if I literally can't remove this index using a some using my current b, I'll continue. Else I'll insert the one exactly behind. This line I just wrote because I was in a hurry and I didn't verify. You can just erase all of this, no big deal. And I have int left j. I am binary searching till the most ahead index I can go. As you can see, this is my prefix sum. It has to be less than equal to bi.
Don't really need to do binary search because it's just linear time.
मल्टीसेट में क्या स्टोर हो रहा है?
हाँ,
मल्टीसेट में क्या स्टोर हो रहा है?
multiset में the minimum, the values with from which I can transition. Basically, I could have, so let's remove all of this. So let's assume a2, a3, a4, a5. So let's assume I could have transitioned all the DP, like I could have transitioned all of this thing in a single this thing in a single pass. Like all of these are less than my b1. But Now what I did was I transition. Now I reached some value x. So I can take this x also and still transition ahead, right?
हाँ
So I store this x in a multiset. I store this 0 in a multiset. So values I can transition from. I would have some y here. I store this in a multiset. I'll have some z here. I store this in a multiset. So A4, I can transition from a 0 till A4. I can transition from a y till A4. I can transition from a x till A4. I can transition from a z till this A4.
A4, how can you transition from X to A4?
How can I transition? Basically, I have removed all these elements and now
हाँ
I'll remove these two elements,
अच्छा okay.
right?
हाँ
I'll remove these two elements. Same
then
thing with the
multiset
y.
में अगर
So it is
prefix sum
sorted.
store करने की
It is sorted, right?
आगे
So
की prefix sum है
yes, not because it's a prefix sum, but I am storing all these values and these are sorted. So I take the minimum value
हाँ
always. And when the time comes, let's say I can't, if I take A1, then I can do only till A4. So I'll remove 0 from the multiset before I enter A5. Why? Because I can't transition from a 0. That is why I am storing the 0 at an A5. Understood?
हाँ
So this is how my solution works. There is no need for binary search. You are correct, but that is a thing that struck me, and less brain cells required, and it wasn't harming my complexity as much. I hope I have not FST'd. So yes. And again, the next question was just counting. So while counting, when you
Wait, let me
transition,
share
you
the
just
youngest solution.
share that, please.
Crazy.
Yes.
No, it has stream only.
Stream.
I'll explain. So the legend youngest solution.
Boom, boom.
Basically, it takes in the input. Like just this.
Wow.
Crazy. So this is the first, like, when is it -1? When your biggest number only can't pick the biggest A. Like you can't divide the biggest A into anything. You can't choose the biggest A only. So you put -1 here. Now you take a prefix sum.
Of A.
Now what is this magic? Yeah, prefix sum of A. Now what is this magic? Crazy shit. I'll explain. So
Magic.
yes.
My jangly.
Very good. Let's say my prefix sum is, I'll take an example.
First.
अरे मैंने तभी लास्ट टाइम उसको पूछा था तो उसकी टीम बन गया है बोला उसका टीम है
Please mute.
Sir, mute. Sachin sir, mute.
अभी पूछने
ऐसा कैसे
Janil, you can mute him. Just
सही जगह आगे
right click. अरे right click boss. Double tap. Mute ऊपर.
Mute.
Up. Mute. Sort.
Now this is the array. My prefix sum becomes 9, 16, 19.
निश्चित है वीरम
Eh?
नाले चले और ये
Wait.
शुभम देशवाल
Prefix sum.
हाँ
Mute.
मुझे डरा कि prefix sum की कैसे round कर रहा हूँ.
हाँ?
So now this is this. Let's take 11. Okay. From 11, what all can I make? I'll try to maximize my this thing. Like from 11, let's say what else can I make? Let's say I can make 9 directly. So I do like basically 2 minus 1 here.
अरे zoom out.
Well,
Zoom.
array.
Not. Increase size and zoom out.
Firstly, everything is, let's say, infinity. I can't reach any of them first. Okay. I have an array. Infinity. 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 Okay. So now firstly I'm taking 11.
Hmm.
So 11 till how much of a prefix sum can I take? I can take only till here,
Hmm.
and my cost is 2 minus 1. Right.
Hmm.
So I change this to 1. Now when I go here, I see this I can take, right? This entire thing. Actually this entire pura thing.
Hmm. Hmm. Hmm.
Huh. So yeah.
Oh, so he's just greedily selecting
Yeah, I just grade this one.
till what I
How do you-
rank I can take. Oh wow.
Yeah. So now
Oh,
you
but that
took a
won't work
1.
in the next
Now
one.
from here you can go to you can directly go here, right? So you change this to
Ah.
2.
No. Okay,
Hmm.
understood. Ah, okay, Bavij. But this
Yeah.
same thing won't work in the hard version.
Just a smaller tweak.
No, no, no. Hard version you need number of ways.
No. I checked this everything. So his base algorithm is same. He's just counting my added this part. That's it.
Ah, Bavij. Bavij. Jiangli sir 2 or system testing done. I'll submit D1.
Almost done. Like,
I'll submit D1 now.
done,
D2.
done.
Done. Yes.
Yeah.
Time to submit. I hope AC. Yes. Let's submit. D2. If this is sad sad.
Yeah, yeah.
Wait, bah. Yeah. Uh,
वो
हाँ,
वैसी है क्या?
correct thing. Let's see. Ah, shit! Ah.
क्या हुआ?
AC.
AC D2 भाई
Most
साहब
probably.
भैया D2 होता मतलब आप ऐसे टॉप 350 में होते.
Yes. 5 minutes after
भाई
contest, you ACD2 sad because of one small bug in
D2
code. Yes. Because one small bug
भाई
in code. Here, small bug. You- Ouch.
D2
Yes.
अरे भाई
But it's basically the same thing that I'm doing for D2. You just calculate the number of ways. Like when you transition, you can just always add things. You can add things from the
मुझे
internet.
ट्रांजेक्शन एक्चुअली उतना ठीक से समझा नहीं, मैं कल देखूंगा.
So transition is basically huh, the issue is that you don't write iteratively, na. हाँ.
नहीं, आई राइट इटरेटिवली, मैं रिकर्सिवली सीख रहा हूँ अभी.
Oh, you write iterative or what? So
हाँ
just think of it this way. You will so in a DP array, what
या
usually happens is that you transition from this to this point, right? You like
या
take the pre-computed values till this point, and then you do some sort of operation and you reach your final point. You take a
हाँ
pre-computed value, you do some sort of operation and you reach this final point, right?
या
So what I am transitioning is I have computed the min value to remove all the prefixes, to remove all numbers till this point, this prefix. You
computed
understand?
the values to remove what?
all the numbers till this, basically remove this
Okay,
prefix,
हाँ.
right?
Okay. Yeah.
Now
अच्छा
if
हाँ,
I
like
want to
iterative में तो
transition
normally.
here, I will take this
Yeah.
prefix and come here.
Your stream is not there, so.
Oh, sorry.
अच्छा
Wow.
स्ट्रीम कर रहे हो आप कुछ?
हाँ.
मैं भी ऐसे ऑडियो से ही समझ रहा हूँ.
Wow. But like you go from here to here, right? So you're
हाँ.
transitioning from X to this point. But here you can have to
Right.
transition from X to this point also, X to this point also.
हाँ.
And there
Yeah.
will be one point where you will not transition from X. Basically that point
Because the
where,
prefix sum is too big.
exactly. So that point you remove
Okay.
X. That point you remove X from the multiset. And you will always transition through the minimum value, right? You won't transition with the max
हाँ.
value.
Right.
Like you have an X, you might have some Y here. With that also you can go. But let's assume,
X से जाना better है क्योंकि
because X is smaller, you are
हाँ.
applying the same, so it will be Y plus M minus I, or
समझा मुझे, like the
X.
leftover array will then have a smaller prefix somehow.
Yes, X plus
ये
M
X won't be included.
minus I. So if Y is smaller, I'll choose Y, right? And
Yeah.
to count the number of ways, I just need to, what I need to do is, if X and Y are equal, then I can store them in a map and sum of ways. And if X and Y are unequal, then I'll just add the number of ways of Y. As simple as that. So basically you can store them in a map instead of a multi-set afterwards. And always get the
Okay.
smallest number. Understood?
हाँ समझा.
Huh. So this is,
Crazy.
yes. So you store in a multi-set and you remove the X here. So now on, you no longer can use an X from this index. So you probably can use something like this, which is a Z. And your Z is, let's say, removed here. So on this index, you won't be able to use your Z. So that's it. That's what you have to do at the end of the day. But yeah. Any
Hello.
more doubts?
हेलो
हाँ हाँ.
कुछ जनरल है तो सोल्यूशन पता है वो समझा नहीं.
A Genil solution. Oh, the Sachin boy band.
Jiangli.
Okay.
अरे I saw I one.
Jiangli sol. रुको भाई. Let's see.
उसमें टीएलई कैसे नहीं आया उसमें 3 लूप्स उसके हैं.
Because
The
constraints
third loop
is n cross m is less than
n
equal to
स्क्वायर में समझा पर
3e5.
उसमें n क्यूब नहीं जा रहा.
नहीं, binary. My solution is n cross m times log n.
Are you talking about Jiangli solution?
Oh, Jiangli
In that,
solution.
the thing is, the J only increases. So at most you're increasing I to n and J to n. So like 2n हो रहा है at most.
Okay. अच्छा okay.
This. It's increasing till the prefix, right? So J is like, you can
Just
think
increasing. You're not
of,
resetting it back. That's the main.
like if J is increased till here, it will remain here, and J will reach here. That's it. J will just reach here. After that, it won't increase. And if you reach here and stop increasing, that takes n complexity, right? Like on every step, you just move J ahead. And at most, how many times J is moved ahead? N times at most, not more than that. So this J plus plus will run at most n times, irrespective of whatever is here, because it never
Okay, so
starts
while
from a
loop-
zero.
So while loop runs n times and
Not
for
n
loop
times,
runs
not
n.
n times. While loop runs total of n times. In the constraints they give, na, that sum of all n is less than equal to 1e5, right?
हाँ.
So same times, the sum of all times the while loop runs is less than equal to n. It will run only n times. Sum of all times the while loop runs is less than equal to n. This is what I mean to say.
अच्छा मतलब there is a pointer sort of thing क्या
Exactly,
कि
exactly,
pointer ही आगे
exactly,
बढ़े
exactly, exactly,
अच्छा okay
exactly.
समझा
हाँ, exactly. There is a pointer. हाँ. Any more doubts? I should have solved it. Shit. AC. Magics.
मेरे को और एक डाउट है पर कॉन्टेस्ट का नहीं है
हाँ हाँ.
तुम लोग कौन से सेंटर्स में जा रहे हो
एक
I
मिनट,
think-
एक मिनट, एक मिनट. Let's end.
Bye.
Bye bye.